I decided to do my project on continued fractions. And so what I learned is that continued fractions can be finite or infinite. This is the formula. So a0 plus 1 divided by a1 plus 1 divided by a plus dot 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 all the way down to an. So here's an example of a finite one. So you start with 1, then you add 1 divided by 2 plus 1 divided by 3 plus 1/2, or excuse me, 1 divided by 2. Then you can change this around to 1 plus 1, 2 plus 1 divided by 7 over 2, and when you divide a fraction, you flip it. So it becomes 1 plus 1, 2 plus 2 sevenths, which gives you 16 sevenths, and you have 1 plus 1 divided by 16 sevenths. And again, you can use the reciprocal. So you end up with 1 plus 7 sixteenths, which gives you 23 over 16. So that's a way of writing a rational number. And you can actually work the other way to find it. So if you start with a fraction, you break it down. And so you do 89/37, which would be 2 plus 15 over 37. And then you say 1 plus 1 at 37 divided by 15. And you continue all the way down until you get down to what you started as something similar. Then over here is kind of what you started with. So it's a continued fraction. So again, you can use finite continued fractions to write rational numbers, but you can also use infinite continued fractions to write irrational numbers. So here's an example for 1 over 2 repeating. So you can say x equals 1 plus 1 divided by 2 plus 1 over 1 plus 1 dot dot dot. And you would simplify this by solving for a quadratic equation.
Square root of 2.
And you would get down to your answer being 1 plus square root of 3 minus square root of 3 divided by 2. And
Square root of 2.
that makes it an irrational number. So you could rewrite it as 1 plus square root of 3 divided by 2, or 1 minus the square root of 3 divided by 2, which makes it an irrational number. I really was interested in continued fractions, and so that's why I picked this one.